Hello, my friends. Thank you very much for subscribing to our channel. There are 16 identical squares of 4 rows and 4 columns. Let's mark all the vertices of these squares, 5 by 5, for a total of 25. By connecting a set of 4 vertices, we may sometimes construct a new square, of course, including the original one. Then, among the newly constructed squares, how many kinds of squares are there with different areas? Why not give a try, and we will come back soon. The original square has the area of 1, which is recorded as the first kind. There are also several similarly simple cases. A square consisting of 2 rows by 2 columns of the original ones has the area of 4. 3 rows by 3 columns, the area is 9. 4 rows by 4 columns, the area is 16. Next, we will discuss some more complex cases. In addition to the cases of using the side of the original square as the side of the new square, we can also use some diagonals as the new sides. For instance, if we use the diagonal of one square as the new side, and then plot a square. Its area is 4 times the half of the original square, so it is 2. If we use the original diagonal of 2 rows by 2 columns, and then plot the new square, the area is half of the total area of the whole figure, which is 8. If we use the original diagonal of 1 row by 2 columns, plot the new square. In addition to a small square with the area of 1 in the center, there are another 4 triangles, with the total area of 4, so the total area of this square is 5. Finally, we plot a square with the diagonal of 1 row by 3 columns as the new side. In the center, the area of a small square is 4. And there are 4 triangles left, with a total area of 6, so the total area of this square is 10. Except for those cases, in any other way, it is always impossible to plot a new square within the specified range. So there are in total 8 kinds of squares with different areas. However, if we wanted to prove that there are really just these 8 cases, it would be too difficult for the students from the 5th grade, so we'll just give a brief explanation here. We arbitrarily select 2 points, and connect them to get the side of the new square. It spans m rows and n columns. The area of this square is the square of this side length. According to the Pythagorean theorem, it is equal to the square of m plus the square of n. And this area cannot be larger than the area of the entire figure. In addition, m and n cannot be both 0 at the same time. Exchanging m and n doesn't make an essential difference, so we just need to find the solutions in the case where m is not bigger than m. When m is equal to 0, n can be equal to 1, 2, 3, 4, and the areas are 1, 4, 9, and 16 respectively. When m is equal to 1, n can be equal to 1, 2, and 3, and the areas are 2, 5, and 10 respectively. When m is equal to 2, n can only be equal to 2, and the area is 8. There are really only 8 solutions. Thank you for watching, and see you next time.